Yeah. So it's way cheaper to buy a new laptop.
It asked me if I meant something.
My plan is to try to get the people that I work for to send them to buy a new laptop.
Okay.
Cool. That's my goal. We'll find out tomorrow.
You want some? Anyone a little mail? Careful. Just be careful.
What you say?
You don't live at Starbucks or something?
Not necessarily, but it makes
Oh
a
god.
What is it? Pumpkin spice? I
Okay, you don't need to use commands to block it. You just use these tabs.
Really? Wow, that's nifty.
better than
Yeah.
the last one.
So I suppose that makes my
It's so
presentation
much-
pretty fucking
It's,
easy.
that tastes
Well,
so
pretend they
much,
don't exist.
2 caramel vanilla instead of classic splash of cream.
Just look very
Honestly, well,
I don't
how do I
even
save
last time.
Yeah.
what I've written?
I don't. Crow would know.
Save workspace?
You know,
No, I couldn't.
just give me my normal cappuccino and I'm fine.
Try it.
I don't know if that's a thing. X equals 10.
No, I don't drink that stuff.
Save workspace.
I'm also a germaphobe.
Yeah.
You're being a baby.
I'm actually very much a germaphobe when it comes to foods and drinks.
Yeah.
Really not.
Huh?
So if you're here for the first time, you can find magnifying glass in the computer and type the MATLAB. Make sure that it works. That's it. The rest is simple. So on coming Friday, there will be presentations that I hope everyone signed up voluntarily. And we went through best half or like longer half last time, and now we'll about mathematical aspects of using MATLAB. Now we'll go through the more technical. So for the sake of good weather, we should finish earlier, I hope. Visualize a matrix. So to visualize a matrix, we should have a matrix. Let's try to feel something and so probably there will be a little smarter ways. Let's do. How did we? Oh, preferences to make bigger font. Preferences. Fonts. Make something huge. Okay. Good. No, let's. I'm going to try several commands and see which of them will look nicer, and then I will attract your attention and recommend to use. But
I don't know.
okay. So I think this command is sufficient. As soon as you have a matrix, if you do this bar 3, it doesn't. It's not the bar where you take clickers. It's bar like histogram.
Oh.
And see, 1, 2, 3, 4. Whatever elements of matrix are, it's just show them up. I don't know what can you do there. Maybe generate some more interesting matrix, like find a function that we will be tired if we fill any matrix bigger than 2 by 2 by hand. So it should be some function. maybe you can set up vector, same as we did before. So just, I didn't do anything reasonable or smart. I was just playing like kids break the toys in order to order them. So I'll just bring the commands back. So we did set up the axis, and then we did define the two functions, like one sine, another cosine. I didn't have an imagination sufficient to design something better. And then, remember last time when we were talking about the dyadic products? Can you bring it? When we were covering, yes, dyadic product here. So if instead of multiplying in a normal way, row by column, you do it column by row, then two vectors generate a matrix. Right now, there is no science behind it. It was just for illustration. But in case your future mathematical experiments or homework generate bigger matrices, you just do this bar, and it will bring a way to visualize a matrix. Okay. No one of us can be absolutely knowledgeable about this stuff, so we always can, because we were not writing this code, the method, the actual software. So why don't we try the help? Probably most of us will not read it through, but the person who is, I think it is Beth, who is presenting this subject may look more in more details. What is here? If it is not boring, tell to us. If it is boring, just do not tell. But when you read help, I don't know about you, but I feel bored and lazy, so I never read it from beginning to the end. But at the bottom of the help on a given subject, it shows something that is of the same area. So it would be, if Parse 3 gives this elevated parallelograms, maybe some of those will show something similar but in better visualization. And the bar without 3, it is regular histogram. It's practice it. So like, if I do plot y, it will be boring. If I do bar, so just show histograms that we typically know. Okay, enough. Any questions about this subject? Okay. If one of the subjects is your future presentation, you may keep making screenshots and copy it into PowerPoint, just to save you future time. In case you haven't installed MATLAB on your microcomputer, then you can collect enough information just in this session, and then just polish PowerPoint for briefly. It shouldn't be like very time-consuming activity. Okay, what is next? 2D plots of 1D functions. Okay. Let's generate some function and try to code it. Again, let's look what they offer. And the goal is not to read it in all details, but maybe it will give a prompt to something interesting. Will you see the symbols if I use a little more humble font? Otherwise, we are coming to a limit when it is just one symbol on the whole screen. So the list of these commands is likely being related to the plotting. So the thing that we all did last time is the regular plot. But right now, x, z, we may plot two functions at the same time. And if we are looking to sell your figures, well, not these ugly figures, but something better that you generate in the future. See, you may make them of different colors and different styles of different styles. I think just the styles will be the next subject. Let's go further. Remember complex exponential that accumulates phase and makes a spiral? One day we may want to plot it, and if I would be less lazy, probably I would make, instead of hand drawing, computed animation for the course. So if we do have the exponential with imaginary unit and then argument, it means like on x-axis it is cosine, on y-axis it is sine, and it is three-dimensional function of one argument. So two functions but one argument, and we may want to plot them simultaneously. Why don't we guess that plot 3 is exactly what we need? Well, right now the argument is defined rather poorly, so you are not invited to admire this specific figure, but in principle it is what we need. And look, here there is a little symbol of curly arrow, so you may arrange it in space in a little different way so that you see it better. And some people hate all mouse operated commands, which I cannot blame, because like if you're not sober enough, you can miss the mouse. But if you are typing every day, you probably will not miss the symbols, or you can dictate to your cell phone. So for arranging your image at different angles, you type view, and then there should be some arguments. Probably it will, what I remember for sure, if you type view 2, it will make projection to one of the axes. So it changes the angle at which you're looking at this spiral image. Okay, enough with lines. So it was a case when you do have one argument and two functions. But there could be a case when there are two arguments and one function, right? So our Z, what did we use? Bar 3 W. It is the case. So we can x is one argument, y is another argument, and height is the function. Or we can do it from scratch once again. Maybe with finer resolution. If we are speaking about functions, we can make a little bit more points. And if you suddenly forgotten which objects you are working with, you can check dimensionality. So if it is one dimensional, it will show like matrix 1 by whatever, 13. If it is square matrix, the numbers here will be the same. So you see the tool, this bar 3, which is designed for visualizing matrices, looks a little too busy. too many lines. So I find some other plotting tools that will remove the lines and maybe encode your two-dimensional functions with color, right? Something like this. Why are we doing it? What is the relation why we spend time on the exotic drawing? What is the connection to the course? So even if we do not jump further than we are right now, one of the problems that we know how to solve, and you have it in your record of successful solutions, is propagating one-dimensional wave function forward in time. So one axis is position, another is time, and the third is wave function or wave function squared. So we will need to plot such functions and analyze them. Just this one is not wrong, but it is a little ugly. So you'll better find a better representation. Well, one way is a contour, which makes isosurfaces, so lines where the function equals to the same number. And if I do not trust my memory, I just look for help for this keyword and see what else does it show. Well, no, I do not like it. I have something better in mind that you all may like. Let's try, instead of contour, to do waterfall. So it splits the function on slices when one variable is fixed and another is changing, and draws several functions while color coding the height. This is better. This is something that we may use in the future. Let's see what. Oh, mesh looks another option. Let's try the so it is similar to what we had in bar 3, but it doesn't show these black lines. It makes it well, it connects both benefits of the contour and bar. And if we select the density of grid points high enough, then we can get the continuous map. Again, it is not the image to brag about, it is just some random two-dimensional function. Later we will have something more scientifically reasonable. And if you are planning on presenting it, you may play it and make screenshots and record them into PowerPoint. Do you do? Okay. What else? So there is another command surf C or surf L, but they are not better than mesh. It's just another possibility. Okay. Is it enough for the subject number 10? So you got an idea what we may need for the course and how you can match the needs of the course and please the rest of the class. Well, not please, but inspire, help, professionally. Three-dimensional plot of two dimensions. Yeah, I think we've covered the subject. If you have nothing to do and you want to dig deeper, you may check how to do polar plots, which will be not a big deal to find. Okay, done. Format figures. So let's do something. Maybe less ambitious. Just simple plot of what will happen if you click on the figure? You select it, right? But if you click twice, it will open some mouse-controlled panels that allow to format it. So you can just check the thickness and style of line, and you can add. Well, symbols are not very nice here, but in principle you can do them. They're ugly. No, let's not do it. So, in addition, if you are looking for again, to sell your figures, gray background, I don't know who designed it. It was a bad idea of designers of code. But you can click on it and there will be a pop-up menu here to change the color. What else? What else is bad in this figure? If you think of the journal style quality.
No axis labels.
Well, you just type X label angle. Don't forget the apostrophes. Whatever. Radians. Phi divided by pi. If you are aware of LaTeX, give me signs if you ever heard this word. Okay, then you can use put some simple mathematical expressions right away there, so it recognizes the LaTeX commands. And for again, small fonts means ugly. Well, big fonts are also ugly, but it is visible and people can understand what are you doing. So you change make large fonts, and if you double click on the axis, there should appear an opportunity also to change the font of the ticks. So now it is something that you can push to the journal. What else? frame is too thin, well, right now we do not care because we are too far from selling our figures. But if you click on more properties, there will be several, I don't know how to tell, descriptors that one can browse through, and point width, 0.5, 3. So now it is a thicker line, and we can also start a little bit earlier and define y-axis in a little wider range, so that the line itself doesn't overlap with the frame. Okay, and then you just copy the figure by printing screen, or print screen. Where's my print screen? Here. Print screen. Print screen, or there are options to export figures, like print or save, and then when you select this option, there will be save. If you try to save the figure, there are options to choose one of the popular styles that also can be placed in like Word document or PowerPoint. Like best seen function. And then you find it on a disk and plug it in. So please try to make screenshots and copy paste. Was it reasonable?
Yeah.
Matching the goals of the course? Okay. So I don't care how you do figures later. But to save time, if you do calculations in MATLAB environment, you may want to prepare figures in MATLAB environment too, to just spend less time. But if you are a big fan of Origin or Excel, there are ways to export data and put in other environments. It was not a question. It was not a question.
No.
Okay. Aha, animations. So when we met, for the first time here, I think one of you, maybe it was Braden, asked, is it possible to animate these figures and make them to move? Like if we consider traveling wave, can we, instead of making two-dimensional plot, can we make it to travel through the screen? Did you try to run the code that I sent by email? Have you seen an email 5 minutes before the class started?
Saw it, didn't open it yet.
Try to open it, run it with MATLAB, and maybe I can keep silent, you'll see everything yourself. So, to get this little code, and you see it overlaps a little bit with one of the next presentations, with the last presentation, like how to make scripts. So it is already a script, and if we run it, so I suggest, for the sake of time, we'll cover other subjects and then invest a little bit more time into this one. So it did work on different version, and debugging would take another maybe 5 minutes, but let's complete other subjects first. So we are skipping movies and going to writing variables into file and reading them from file. Okay, just if you type save without any arguments, it will save all variables that are active in the memory. And then you close, open on the same computer. If you open it on another, it will not work. And then type load, it will bring up all variables back. But if you are looking into forwarding your data from MATLAB to your favorite Excel, if someone likes it, or GNU plot or Origin, then you may want to save your data in the text file, not a coded plain text. And then this ASCII, it is a code to save data as a plain text. Then you give the number of variable and name of the file. I always forget what is the variable name and what is the file name, so I just try to keep them the same. But if you type help save, you will discover which one is which. And then if you type in the command line pwd, which is password detection, you will identify where you are working, at which directory. Well, if you prefer mouse-operated commands, it should show the folder in this line. But maybe the font is too small, or you want to be 100% sure, so pwd shows this pathway detection. And then you may go to the File Explorer and navigate to the directory that you have identified through this pathway detection and see, like we were saving this YYY. You see that there is a file YYY, you can click on it, and then it will be offered to open in one of the file readers or file editors. So right now it was a boring file, it was just a list of arguments, but you can see that it is the same data starting like 0.1.2.3 here, right? And with the files that you have opened on yours just through your regular operations in the whatever File Explorer and Notepad, you see them. And such format of files is something that you can forward into Excel or whatever. You know how to put data. Which question you would like to ask right now? Okay, which question I would ask myself if I would be sitting on one of the tables there? If we want to use this data for plotting in Origin or Excel, how can we save two lines, X and Y, in a single file? Right? Do you have the answer? Let's see through our list of experts who should have the answer. Andrew is not here today. Austin, not here today. Ah. Okay, I need to answer it myself. So how do we define the matrices? If in the silliest and simplest way, we just open brackets, type numbers, make line break, and then when matrix is done, we close the square bracket, right? Or we can compose a matrix out of two vectors. If you have two columns, two vector columns, we can just define new matrix as the vector 1 space vector 2, close the bracket. For example, so we have this strange YYY. So what should you get in this record? What will be the size of this object? How many rows and how many columns?
Two columns and then the size of.
Yes, yes. So let's do something more that has sense. Sine of and then we better define it this way. So now we have a matrix where first column defines the argument and second column defines the function. Right? The matrix is not square. It's just 2 by whatever, 100. But no one forbids us to save this matrix and explore if we do have this data in the directory. So you can navigate by mouse, open with whatever we prefer. And see, there are two columns, and linearly growing first column, and second growing slowly. And if you scroll further, it should go back to negative as it is expected for oscillating sine function. So whatever data, right now the data were fake data, were just example. But if you generate something through a numerical oscillation, you can just arrange it in the right array, right matrix, save, and then read again from your next code if you need a chain of codes, chain of scripts, or you can just read it for visualization but by your favorite software. Make sense? Now, how do we check which data are available in the random access memory? Is type who, right? And we have so many, well, not too many, but some variables. So if you type clear, you have nothing. You have wiped off the memory. But suppose we have a collaboration inside the group and your classmate provided you with data. Maybe this matrix with sine x, very valuable data. So how do we restore this file back? Okay. So you load from the file. Here I know for sure that this is file name, this is variable name. So now it is restored back. So the memory was empty and we did read this data from file. Which question would you like to ask? Is it sufficient on this section? And which question I would ask if I would sit on one of the tables? Before we merged two columns, they were separate arrays, separate factors. And we knew how to plot them. We just type command plot and then vector 1, vector 2 for this data. But if you have them both in one array, how do you plot them? Any ideas?
What was the question?
Huh?
What was the question again?
So we do have non-square matrix which represents some numerical data. And we want to plot x versus y using just this piece of data. So the question is how to parse one column out of matrix. Let's check if we have any experts who feel responsible of this. Derivative vectors. No, those are two most important persons in our class. Okay, it's my time to answer. So, how to parse? Parse vector out of matrix. You can try something, make an experiment. Try these two records and check which one of them will work. So the column means run over all available values of indices. So which one is working for this object of two columns?
First one.
First one? Let's check. So column first. Okay, so we can, this means all elements in all rows by fixed column, right? And we can write restore xxx equals this one. And follow the same pattern, column, comma 2. Just, I want to make sure that it was not a, since we always do new figure, mention new figure and repeat the command. Okay, so it is the same set of data that was restored from the disk, right? So please give me signs, lift hands if this subject needs more comments. Please.
Say you're reading from a file that also has text. Is there a way?
It is our best interest to avoid such files.
Okay.
At maximum, we can create files that will contain text. But it is possible, but we are not here to program. We for quick processing of numerical data. Not like we will not make the buttons to click mouse with. We are taking minimal skills needed to propagate electron forwarding time. But if you figure out how to do it, you can report it to everyone. Is it sufficient for this subject? Or are you doing screenshots? And...
Yeah.
Scripts.
Is that
Who's Luke? Not here? I don't know whom I tell him. Well, maybe it will be recorded and he will watch it. But we just develop some secret knowledge between us for the rest of the course. So nothing special here. You know so many commands. If you just write them line by line in file and then execute this file, just click on it, it will run. That's it. But let's practice maybe some simple things. Maybe it is the only command that was not included in what we did before. So if you need to repeat an operation again and again with a little different parameter, you just type this for end. But do not, well, you can try anything, but it doesn't make much sense to write it in a command line. It is better to open a designated file, save it in the same direction where you do all works, and name this file like, you can give it like my best or whatever, my script, and always end it with .m extension that the MATLAB recognizes that it is designed for it, for MATLAB. So if you do not know where to start, you just type new. You see here new script, and it will pop up in the window above, command window. And then you can put in everything you need. If you need a sequence of operations to be executed one after another, you just write them one after another. Like Gesundheit. Thank you. Check what works better. So like loading, saving data, plotting images, making matrix operations, and I will try to type something that may help later to the questions that Braden is going to present. So I will make slow but sure, hopefully, effort to make the animation, but through doing this couple of lines programming, we will see for everyone how it works. So we can do the simple things that we do all the time, like define range, Okay, I will be creative. No, cosine instead of sine. Okay, I'm tired, and I don't want to type these commands again and again each time in the command line. So why don't I save it? Save as and give it some name. And then if I'm typing pwd, it shows in which directory I am. But there is also command ls, which stands for list, and then it shows the script file. Well, it would be too ambitious to call it a program. Script, which is stored in this directory. And if we are skeptic to whatever MATLAB is doing, we can go to File Explorer, identify that this file did appear there, and we can either double click and funnel it into MATLAB, or we can try to open with something else, not with MATLAB, but let's say with Notepad, and see it is the same thing that we just typed, right? Again, if you're very skeptical with whatever MATLAB is doing, you want to only write, run scripts there, you can prepare them in other text editor, save in right directory, and then run from here. So you discover that there is. Let's focus on the. There is a triangle symbol, same as on the DVD players, to play the code. But there are different styles. Again, if you want to switch between mouse-operated commands and you want to do everything in command line, you can just type the name of the code in the command line. So I bet that if I... It's also... figure means open new window for a figure. Save. And here I type this exercise 1. See? You just type the name of the code and it does whatever it requires you to do. Any questions at this point? So it's simple enough. Probably you knew it or you would guess it, because it is very natural. Well, let's keep going. What is running wave? From the very beginning of our course, So running wave is when the argument of this wave function is being shifted according to velocity. At each new time, it is different. So we can just do it. So please try to do it. Bren, does it answer your question? Okay, but it doesn't answer my question. So right now we did hit two birds with one stone. We developed a little code, a little script that you may want to repeat and get this running. And second, we did some primitive animation. But let's be ambitious and put a third bird as our target. So 3 birds with one stone. In order to run this animation, we always need a computer with MATLAB activated in front of us. But if we are in a rush, if we are making a presentation, if we are away from home on a conference without our microcomputer, you may want to have something more reliable and standard. So there is a wish to convert this little animation into something more typical that you can play on any equipment, like .avi file or MPG4. So some true animation file that you may upload to YouTube or plug as animation into PowerPoint. So I will try to bring necessary commands to complete it into here. But if you got the answers for your subject of interest, if you know what to present on your free view presentation on Friday, you are free to leave. So it's completely frivolous. It's your volunteering effort. You can sit and play and prepare your slides. You can leave if you like, or you can wait until I figure out how to debug these little things. So nothing is mandatory. Do not make yourself bored by waiting for me playing this with the computer. I see.
Yeah, I got this, I got all that. It's those numbers.
Oh, and just watch it wide.
Yeah, but I can't figure out how to just do one line.
Oh, yeah, because you probably have to try to plot like a separate thing for each. Yeah, I'm just figuring out like how to actually store variables. Well, not just now, but I mean, yeah, I figured out that like each variable is just basically how far are you making it, like how far is it going.
Yes, that was kind of my problem. Do you know what the normalization is out from?
A free one? No. You figured it out. Just do the integral, bro.
What if it's just divided by
I don't think that is. You know what? You just go right ahead.
What does that even mean? Bye-bye. Yeah, at least I made one line now.
Yeah, right?
I don't know what that
You
means.
gotta divide it by x.
Probably confidence.
Okay, so there is a good chance that it was successful, and I will share the code after proving that it works. So first, I looked into the help for video writer. Second, in the help page for video writer, at the end they give an example of something that should work. So I just copy pasted commands that I like into the code that we wrote together. And let me identify them. So for video. So first command is to first command was to set up output file. Second command is open string. Then communicate that. So video is just a set of images that replace each other. And then after plotting commands are complete, one should pick up the image from screen. So it is, in some sense, it is same as print screen, analog of print screen. And then this data from printed screen should be forwarded to the file, to the stream. And at the end, the stream should be closed. So if everything worked fine, then this file wave.avi should contain the animated movie. So look here in our File Explorer. There is this wave AVI file of 3 seconds duration. Let's try to click and see what happens. Yes, it works. So what we want to do is to go to the PowerPoint and insert and find where is the insert video or insert animation. So you see here video from my PC. So you find this wave, you save it, put it here, then you can save the file. So now if you decide to run the PowerPoint, and even if you send it by email or run on different computer, this animation will be with you, independent of whether the computer is equipped with MATLAB. And sometimes when you go from one version to another version, the equipment may fail, or there could be something may not work, but it is something more reliable. Also, in recent days, many journals accept animations and videos as a replacement of figures. So it is just on the start, but it will be more and more in the future. So making little clips can be a necessary skill of a scientist in the near future. So let's complete this skill. Were you able to run it, or should I send email with this little code?
I got it.
You got it. Okay. You will have hard task to teach everyone to be able to do the same.
I mean, your code is pretty. Stand
Okay.
did pretty well. So.
But on the presentation, your task will be not to show that you can do it,
Well,
but teach others. I will make homework assigning it from everyone.
So for Friday, are we going to be in here, or are we going to be back?
Regular room. And we need to squeeze this over a dozen presentations into whatever, 50 minutes, which is a big challenge. It means that you cannot speak longer than 3 minutes. So I will be like stopping, coming, and maybe unplugging the computer. Done. Next. So let's complete this little exercise by another skill that one day will be requested from everyone in the class. So go into YouTube. Go into YouTube. I can share this little script just in case, so that with guarantee that it works in this room. Documents. this script works in computer class for sure. Okay, so if you are running and it doesn't work, you can just use the script that I shared as an email with everyone. And now, after you do have a animated file, you can navigate to YouTube, and most of you do have Gmail accounts, which means you have automatically have YouTube account. And there is a button. See this button on the top, upload. When you click it, look, and then it offers you an opportunity to select some files from your PC. So you select this file, make some identification that it is my first animation for CHEM364, web number 3, and then you click publish, and there will be a link. There will be a link to this video. So now you can impress the globe with your animation. And one of the homeworks in the future will be create animation, and instead of handwritten homework, just send a link to your YouTube by email. Please make sure you know how to upload scientific animations to YouTube. Okay, I think all program is complete, so I'll stay here to answer questions if any, but from now on you are on a confirmed path to become certified experts in MATLAB programming.
Can we go over the complex numbers again? Last week I got here like right after my part ended, and there's no step.
Please try to guide the discussion, because I don't know how detailed I should be. So is font big enough?
Yeah, I can read that.
I can increase a little if it will be more comfortable. Better?
Yeah.
So square root of 4 will be, yes, square root of minus 4.
2i.
Yes. So,
Okay.
well, you can add something in addition, but basically,
So we're not going super in depth. We're just
well, in 3 minutes you can, well, you may do a fair effort to help your colleagues in the room to become experts in MATLAB. Just looking back on what we did in the course, you may try to check which chapters or can be illustrated with MATLAB. What is exponential of 0?
exponential of 0 is 0.
let's make, if you set up the, let's clear O, set up x maybe from minus pi to pi, plot x comma exponential of x. So exponential function grows if the argument is real. When it is 0, it is 1. When exponential is more than 0, it is more than
Gotcha.
1. Right?
Yep.
Okay.
Forgot about that.
Good. What is exponential of 1?
Exponential of 1.
Mm-hmm.
Well, what's the exponent? Oh, wait. It's 1. It's a line of 1.
Exponential of, let's see, roughly. Let's enhance this range. So exponential of 1 will be something between 2.5 and 3, right?
Okay, so we're thinking for this specific.
Exponential of 1, 2.7. It's just e number, 2.7.
E to the 1.
E to the 1.
Okay, see that.
E to the 1 is,
I was wondering what the base number was. Okay.
no, exponential, it means e to the power of,
Gotcha.
okay.
Okay. That
Now,
makes sense.
what will be the e to the power of pi?
I don't know.
Something crazy. But what will be e to the, let's define e to the power of pi multiplied by I. Just try, before we go, try to guess what it should be.
Isn't it like the reciprocal of that?
No.
5 times 1. So that's the negative square root of pi. No, I probably distributed that.
You cannot do it without over. So e to the power I something, I will be cosine of this argument plus I sine of this something. So what is cosine of pi?
1. No. Cosine of pi is.
What is sine of pi?
0.
So if you take exponential of I times pi, should be minus 1. Let's check. See?
Okay.
Okay. So the whatever we put in here, any real number, it will be some sine and some cosine. So absolute value of this real and imaginary part will be always equal 1. So it will be point on a circle. And if you were following subject that London will present, we can make real part and imaginary part of exponential and just visualize it for our intuitive understanding. Like if you set, you already have this x variable, you can make it a little finer resolution this way, and then we can take z equals exponential of I times x. But then we cannot plot it as a two-dimensional figure because it always have real and imaginary part. But what if we there is a, if you show z, it will be like real and imaginary, real and imaginary. But we can tell maybe R equals real of Z and imaginary equals imaginary of Z. Now this real and imaginary things will be like real, and we can do plot 3 of x or r or l. New figure. See, it's like a spiral coil. So if the argument of exponential is imaginary, and if you look in this axis, it will always change real part between plus and minus 1, and complex, the imaginary between plus and minus 1. And so it is always shows a vector of length 1, but different proportions between real and imaginary. So even if we do not do it, we can just keep it in mind in about complex numbers. What else can we try? What will be this one?
Let's e to the 2 pi I.
Which equals?
Okay, so it's e to the 2 pi I, then can you distribute that back to the cosine and sine?
So this one equals minus 1. So this will be minus 1 times minus 1. Okay?
Yep.
So you may do a couple of such examples and show that method can help us to overcome the barrier, because these complex numbers are counterintuitive, but we do need them for the course all the time. Like, we can do something by pen and paper, but then we want to check if we work correct. What else?
So just do some examples of complex problems and just show the answer.
Yes, yes, and make sure that they do not run for longer than 3 minutes. Just share your experience, like what was new for you, what you were not sure, and after making it, it became a lot of insight.
Okay. Will it, is there ever an option in MATLAB where it like shows the work where it got, or no?
Like,
Like to get from the e to the 2 to get from the problem answer to wherever anyway you don't show its work.
oh, derivation, no.
No?
So it all goes numerical.
It's just an instruction.
So it's not symbolic algebra, it's just numbers.
Gotcha.
right? I mean, literally just like, who's black, who's not, who's black.
Here's that.
Another question. I don't know if it will be helpful for your presentation, but just make sure that you feel more comfortable. If you have complex number where argument is imaginary, phi times angle, and then absolute value, which will be real part square plus imaginary part square plus maybe square root of it. What will be the answer? Look here. Due to whatever. Cosine phi plus phi. Real part will be cosine, imaginary part will be sine, and then cosine phi square plus sine phi square equals what? Yes. So here the answer is also expected to be 1. But let's check.
Oh, okay.
See, let's go into this example and check the length is ABS, absolute value. So it's what? Absolute value of Z. No, not Z. Z? No, all right, it's just not just simple plot. So if our guess was correct, yes, see, it is 1. So independent of what is the argument, it's always 1. So when we do exponential of real argument, the absolute value grows exponentially. If you do exponent of imaginary argument, the absolute value doesn't change. It is always 1. It just changes the phase.
Okay.
So,
I gotcha.
so you may try to experiment here or at home. By the way, it is very, very recommended to have to install MATLAB on your private laptops. We all, as since we are affiliated with NDSU, we have right to do so.
Does MATLAB work on Linux or Mac, do you know?
Yes, yes,
Okay.
for sure. On both Linux and Mac.
Okay.
If you are acquainted with Linux, you may recognize that MATLAB commands are very similar to it.
Yeah.
So
Yeah, I got a dual boot MacBook Pro that has Linux on it, I guess, so.
but I use it under Mac, just
Yeah.
Mac OS, not dual boot.
Usually if I'm doing anything like heavy computationally, then I'm doing it on the Linux side, so. I'll probably and
Yes.
I have a question. So I'm modifying your script thing, but well, why am I getting multiple lines?
Did you?
So the things that I changed your sign, just like a type initials function. And then calculate that 1 over t.
So T is a number and X is a vector. Can you try something? So your argument is not a number, it is something more advanced. So if you want just x squared,
Yes.
or and make sure that on previous instance. What are you trying to run? You should. I was expecting you to do the same as this undergraduate. Open my word is.
Sick. That's what we did. Oh, God, that was trouble for no.
What do you have?
There was a problem with mine, because X is
So it will send you the link.
Yeah.
and I was trying to figure out how to make it a number,
Yeah.
and so I couldn't figure out how to do anything, so I just tried to do this.
Huh?
Try to get it.
Oh, and like
But it made another matrix, and I didn't realize.
Yeah. Well, yeah, because then you're like.
Yeah, but all you need to do is the dot.
Yeah. That's how you do like exponents.
Oh, okay, so what? Okay.
Because then it'll do like a I
Then
figured
each
that out too.
element,
Just a little bit.
yeah.
Yeah, because then that'll give you like an element
Yeah, it
by element
makes sense
squaring
now
instead
that
of like a matrix squaring.
Yeah.
Yeah.
Oh, now it looks so good.
More questions? Okay, then let's stop